Hello, good morning, good evening, good night, everyone. How's everyone doing? I am having a good day because I am going to teach you how to solve this problem called maximum subarray. Um, Now, this is a Leetcode problem. Feel free to solve it on your own first before I go right through it myself. And if you don't want to solve it and you just want to see the answer, like every 99% of all college students, then that's what I'm here for. Okay, so let's look at the problem. So given an integer array of nums, find a contiguous subarray containing at least one number, which has the largest sum, and return its sum. Well, that feels weird. Largest sum and return its sum. That sounds kind of weird. Let's look at this example. Oh, and before I continue, you might be wondering, what does it mean by contiguous? So that means like, given this like array, for example, that has discrete values in each part. Contiguous means like this section right here, 2, 1, negative 5, 4. They're contiguous because although it's not like it's not like a graph, like a smooth graph that's continuous like this. Contiguous means like it has the discrete values that are still right next to each other. I mean, for example, like a bar graph. You know, if I let's see. I should prepare next time. Uh-oh. Oh, one thing I don't like more than Bing. Why do I even have that as my default, guys? It tells a lot about a person. Okay, this is a good example of here. I need a better bar graph. Darn it. Let's just take this for example. Let's just pretend that from left to right, this whole bar graph is like one whole axis. Ignore this axis. Let's just say it's from 0 to infinity. Contiguous means like you can see right here at this area right here, it's one value, next one is the other, yet these bars together are contiguous to each other. That's how I interpret it. So if you guys find a better definition, feel free to ask your friend or Webster or Oxford Dictionary or whatever, man. Anyways, so here, if I want to take this array and I want to find the largest maximum sum, based on a contiguous subarray, the answer will be, the largest sum would be 6, because this part right here, for negative 1, 2, 1, would equal the largest sum equals 6. Now, I can solve this. I can try and attempt to do a brute force solution, but it's not going to be as effective. I think it'll be the best use of our time if I just go over how to solve it myself, like the correct way. I admit that I wasn't able to solve this at first until I heard of this algorithm when I looked it up. It's called Kadane's algorithm. I'll include the link below. So what it does, it goes from left to right through the array, and when it goes through the array, at each position of the array, it calculates what neighbors should it connect to so that its sum will be at its greatest. For example, in here, if it's negative 2, it's going to have the highest, if it's negative 2 and negative 2, if it's negative 2 versus negative 2 plus 1, the value that will be higher would be negative 2 plus 1, because negative 2 plus 1, here. If you look at this, what value will be higher? It will be this one, because the sum of these two neighbors together would equal negative 1, which is greater than negative 2. That's basically what the Kadane's algorithm does. It calculates the highest sum based on its nearest neighbor. So, now if I were to solve this problem, oh, by the way, to decompose this problem, oh, by the way, some interesting subcontext when I was just browsing through how to solve this problem. I didn't know this, but even though it says easy, this thing has like interesting applications according to Wikipedia. It could tell you like, let's just say you're analyzing some sort of protein sequence or DNA structure, and there might be a specific segment of that DNA structure that you can use to understand it using Kadane's algorithm. Or you can use it in computer vision or data mining. That's just so fascinating that some of these problems, it makes sense, of course, that it has those applications right there. And I'm surprised 6520 people was able to solve this thing. It's so easy. Oh man, I got some work to do myself. Anyways, so before I start, I want to initialize So here's what we need. We need a max sum. And for this scenario, I'll just say nums equals 0. I'll just make that as a starting point. And I'll say a temporary maximum sum, which would also equal nums 0. So my goal is, by the time I iterate through this whole array once, I'll be able to return the max sum. And this temp sum will check that in each part of the area, I'll check that if it will be a maximum within this area, I'll be able to generate a maximum sum within that area that'll be greater than whatever I hold right here, and I'll be able to return it. So here I'll start with for int I equals 1, because I already assigned these 0 values. I mean the value at the 0th position of the nums array. I guess, like, even if I were here, I'm just gonna finish this part right here. I mean, I guess a tip if I were to solve this, like, to be honest, I had the idea when I solve it, is that because usually you could solve an algorithm, a question like this, based on using your human instinct. Like, if I were looking at this, I could tell that the maximum sum would be generated because 4, -1, 2, 1 would generate that maximum sum. To do that, you could almost feel it by instinct, like, in a way, like, if you just go through it once, you could feel. Sometimes when you code, you could almost do it by how you feel it, and you could try to, like, translate. The difficult part is trying to translate it into the answer. So in this case, I'll be trying to iterate through this array loop at least once, and then, you know, if I look right here, when I do this instinctually, it'll be so fast that I'll be like, okay, the temporary sum, would that the number in that value, would it be bigger if it were alone, or would it need its previous neighbor to create that maximum sum? Here I'll be like nums I plus temp sum. So because this temp sum is going to be either the value at its exact spot or its previous neighbor. And if I take this example right here, -2 versus -2 plus 1, it's going to be better if it's just its nums value alone. And then I continue on and so forth. And then this max sum right here, this math max, it takes the maximum. It chooses, like, you know, chooses the maximum between the two values you put inside that max sum function. Here in this case, I'm going to compare the current temporary sum, is it greater than the maximum sum? If so, assign that value. Okay, so I'll just go over it one more time in summary. I start with the beginning value as the current sum, just as a placeholder. And as I iterate through, I could use its previous neighbor that I just passed by to see if it will create a larger sum. And if so, I just carried into this max sum variable. If not, then it's just ignored. That's basically it. I guess it is sort of easy. Now, if I were to run this code once, let's hope I recalled this correctly. There you go. That's it. Awesome. Okay. And if I submit this answer, it should pass. That is great. Now, if you find another solution below, guys, please comment below, and I'll pin it to the top so the others could see that as a better solution. Maybe you guys could even, like, communicate with each other, like, what would be a good thought process to break it down and try to solve this problem. Almost how to divide and conquer the solution. To be honest, I don't know. I couldn't think of a good way to solve this through divide and conquer. But anyways, thank you for watching this video. Please like and subscribe, and if you do, I'm going to give you 10 Bitcoin. As soon as you check your Gmail account, you receive a mail from my email address saying, hey, I got 10 Bitcoin right in your account. If you don't have it, account will be open under your name with 10 Bitcoin right under it. Just kidding. Just kidding, guys. I want to emphasize I'm just kidding, all right? Because I don't want to be in trouble for real. I have a life. Anyway, guys, have a good day, a good life. Have a good evening, good morning, and good luck on your interview or coding exam. Cheers.